Hello, in this lecture we will find out the diameter of the semicircle. In the drawing we have a semicircle. We know that AB is the diameter of this semicircle, and we want to find out the size of AB or the value of AB. And we also know that chord AD equals to 7 units, chord DC equals to 15 units in its size, and chord CB also equals to 15 units in its size. Again, we want to find out the size of AB, that is the diameter of this semicircle. The first thing that we will do is to a construction. We will join points D and B by a straight line. Actually, angle ADB equals to 90 degrees in its size, so this is a right angle, and it equals to 90 degrees according to rule number 1. Rule number 1 states that peripheral angle resting on the diameter of the circle equals to 90 degrees. I will read rule number 1 again. Rule number 1 states that peripheral angle resting on the diameter of the circle equals to 90 degrees. So actually angle ADB is a peripheral angle, and it rests on AB, that is defined as the diameter of the semicircle. AB is the diameter of the semicircle. Therefore, according to rule number 1, angle ADB equals to 90 degrees. Okay, so I write it down. Angle ADB is a peripheral angle, and it rests on AB, that is the diameter of the semicircle, Therefore, according to rule number 1, angle ADB equals to 90 degrees in its size. So I'll read again the things that I wrote. Angle ADB rests on AB, that is the diameter of the semicircle. Therefore, angle ADB equals to 90 degrees according to rule 1. Okay, so angle ADB is a right angle, it equals to 90 degrees. In the next step, we will define the center of this semicircle as point O. Then we will connect together points O and C by a straight line. And we will also connect together points O and D by a straight line. Actually, OC, called OC, is the radius of this semicircle because it starts from the center of the semicircle, that is to say from point O, and ends at point C, that is a point on the semicircle itself. Therefore OC is the radius of this semicircle, and OD is also the radius of this semicircle for the same reason. It starts from the center of the semicircle and ends at point V, that is a point on the semicircle itself. Therefore it is the radius of this semicircle. We will define the letter R as the radius of this semicircle. Therefore OD equals to R, and actually OB is also the radius of this semicircle for the same reason, because it starts from the center of this semicircle, that is to say from point O, and ends at point B, that is a point on the semicircle itself. Therefore OB is also the radius of this semicircle, that is to say it equals to R. Okay, so in the next step we will focus on triangle OCD, that is the green triangle. And we will also focus on triangle OCB, the orange triangle. So actually in triangles OCD, the green triangle, and triangle OCB, the orange triangle, side DC of the green triangle equals to side CB of the orange triangle. Both of those two sides are equal to 15 units according to what is given us in the question. So side DC of the green triangle equals to side CB of the orange triangle, and both of those sides are equal to 15 units, and side DO of the green triangle, it is the radius of this semicircle, equals to side OB of the orange triangle. Both those two sides are the radiuses of the semicircle, therefore they are equal to each other. So OD, side OD of the green triangle equals to side OB of the orange triangle. Both those two sides are the radiuses of this semicircle, and side OC is a common side. It belongs both to the green triangle, and side OC belongs also to the orange triangle. So OC equals to OC. It is actually a common side. So actually OC equals to OC. So we actually proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, we actually proved that the green triangle OCD is congruent to triangle OCB, the orange triangle. Again, triangle OCB, the green triangle, is congruent to triangle OCB, the orange triangle, according to side rule. According to side rule. Okay, so the green triangle is congruent to the orange triangle according to side rule. Actually, when you prove that all the sides of one triangle are equal to all the sides of the other triangle, then those two triangles are congruent to each other according to side rule. So from the fact that those two triangles congruent to each other, we can deduce that angle OCD, this angle of the orange triangle, equals to angle OCB of the green triangle. Okay, angle OCD of the green triangle equals to angle OCB of the orange triangle. According to the rule that corresponding angles in congruent triangles are equal to each other. Okay, side OC, angle OCD of the green triangle equals to angle OCB of the orange triangle. Again, according to the rule that corresponding angles in congruent triangles are equal to each other. The green triangle is congruent to the orange triangle, and therefore the corresponding angles, angle OCD and angle OCB, are equal to each other. And if we define angle OCD as alpha, then angle OCB will be also equal to alpha, because those two angles are equal to each other. Okay, so side OCD equals to side OCB equals to alpha. And in the next step, we will focus on triangle BCD. in triangle BCD, this triangle BCD, side CD equals to side CB. Both of those two sides are equal to 15 units because it is given us in the question. Okay? Side CB of triangle BCD, side CD of triangle BCD equals to side CB of the triangle. Both of those two sides are equal to 15 units in their sizes. And so those two sides are equal to each other, and we have rule number 2 that states that in front of equal sides in the triangle, there are equal angles. So I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. So actually, if we focus on triangle DCB, we know that side DC equals to side CB, and in front of side CB in triangle DCB we have this angle, and in front of this side DC of triangle DCB we have this angle. So according to rule number 2, in front of equal sides we have equal angles. Those two angles are located in front of equal sides, therefore they are also equal to each other. So according to rule number 2, this angle BDC is equal to angle DBC. According to rule number 2, those two angles are equal to each other because they are located in front of equal sides. Okay, so angle BDC equals to angle DBC according to rule number 2. And if we define angle BDC as theta, then angle DBC also will be equal to theta. Okay, so angle BDC equals to angle DBC according to rule number 2, and both those two angles are equal to theta according to our definition. In the next step we will define this point as point E, and we will focus on the green triangle, triangle DEC, and triangle, the orange triangle, triangle CEB. Okay, again, we will focus on triangles, the green triangle, triangle DEC, and the orange triangle, triangle CEB. On those two triangles, side DC on the green triangle equals to side CB on the orange triangle. Both those two sides are equal to 15 units in their sizes. So side DC equals to side CB equals to 15 units according to what is given us in the question. And we also know that those two angles are equal to each other, they are equal to alpha. So angle DCE in the green triangle equals to angle ECB in the orange triangle both those two sides are equal to alpha according to our definition. Again, side DCE in the green triangle equals to side ECB in the orange triangle, and both those two triangles are equal to alpha in their sizes. Okay, and side EC is a common side. It belongs both to the green triangle, and side EC also belongs to the orange triangle. It is a common side, so EC equals to EC. EC equals to EC. It is a common side. It belongs to both triangles, to the green triangle and to the orange triangle. Okay, so EC equals to EC. It is a common side. So we actually proved that two sides and the angle included in the green triangle are equal to two sides and the angle included in the orange triangle. Therefore, we actually proved that those two triangles can go into each other according to side angle side rule. Okay, so we can write down that the green triangle, triangle DCE, is congruent to the orange triangle, triangle CEB, according to side angle side rule. Okay, again, the green triangle, triangle DCE, is congruent to the orange triangle, triangle CEB, according to side angle side rule. Actually, side angle side rule states that if you prove that two sides and the angle included in one triangle are equal to two sides and the angle included on the other triangle, then those two triangles can go into each other according to side angle side rule. So we proved that two sides and the angle included in the green triangle are equal to two sides and the angle included in the orange triangle. Therefore, those two triangles congruent to each other according to side angle side rule. Okay, so from the fact that those two triangles congruent to each other, we can deduce that angle DEC in the green triangle is equal to angle BEC in the orange triangle. So those two angles are equal to each other according to the rule that states that corresponding angles in congruent triangles are equal to each other. So angle DEC in the green triangle equals to angle BEC in the orange triangle according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, and if we define again angle DEC in the green triangle equals to angle BEC in the orange triangle, and if we define angle DEC, this angle as x, then angle CEB will be also equal to x. Okay, so actually angle DEC equals to angle BEC, and according to our definition both those two angles are equal to x. In the next step we will focus on chord DB. Actually in the beginning of the lecture we connected points D and B by a straight line. We connected points D and B by a straight line, so DB is a straight line. DB is a straight line. According to our construction, DB is a straight line. Okay, DB, chord DB is a straight line according to our construction, and we have a rule that states that along a straight line, either in the upper side or in the lower side, at a certain point, the sum of the angles are equal to 190 degrees. So I will write it down. Rule number 3 states that along a straight line, either in the upper side or the lower side, at a certain point, the sum of the angles is equal to 180 degrees. I will read rule number 3 again. Rule number 3 states that along a straight line, either in the upper side or the lower side, at a certain point, the sum of the angles is equal to 180 degrees. So, according to rule number 3, along the the straight line DB, if we focus at point E, at the upper side of point E, the sum of the angles is equal to 180 degrees. That is to say, this angle equals to 180 degrees in its size. again along a certain line, along the straight line DB. If we focus at certain point, that is to say, if we focus at point E, on the upper side of that straight line, the sum of the angles is equal to 180 degrees. So this angle equals to 180 degrees. So in other words, angle DEB equals to 180 degrees from one side again. This angle angle DEB equals to 180 degrees according to the rule number 3 from one side, but the size of angle DEB will be also equal to x plus x. Again, x plus x is equal to angle DEB from the other side. So from the other side, angle DEB equals to 2x in its size. So we have the following equality that states that from one side, the size of angle DEB equals to 180 degrees according to rule number 3, but from the other side, we can see from the drawing that angle DEB equals to x plus x. So from the other side, angle DEB equals to 2x. So from this equality, we can conclude that 2x equals to 180 degrees. Two x equals to 180 degrees, and if we divide this equality by 2, we will get that x equals to 90 degrees in its size. X equals to 90 degrees. So actually we can substitute x by 90 degrees. Those two angles that are equal to x, we can substitute them by 90 degrees. So this angle that equals to x is a right angle, and this angle is also a right angle. It equals to 90 degrees. Okay. In the next step, we will focus on OC, called OC. Actually, we connected points O and C by a straight line. Therefore, OC is a straight line, and also OC is the radius of this semicircle because it starts from the center of the semicircle, that is to say from point O, and ends at point C, that is a point on the semicircle itself. And as a radius of the semicircle, it must be a straight line. So OC is a straight line, or chord OC. OC is a straight line. We can say also chord OC is a straight line. and we have a rule number 4, that states that the sum of the angles along a straight line it's very similar to rule number 3, but with a little difference. Along a straight line, either in the left side or right side of the straight line, at a certain point is equal to 180 degrees. Okay, so I will read rule number 4 again. Rule number 4 states that the sum of the angles along a straight line, either in the left side or the right side of the straight line, at a certain point is equal to 180 degrees. So, according to rule number 4, if we look at the straight line OC at a certain point, that is to say at point E, and we look on the left side of the straight line OC, then the sum of the angles in the left side of the straight line OC at point E also equals to 180 degrees, according to rule number 4. So actually this angle BEC, that is a right angle, that is to say it equals to 90 degrees in its size, plus this angle, that is angle OEB, must be equal to 180 degrees according to rule number 4. Okay, according to rule number 4, 90 degrees plus angle OEB equals to 180 degrees, because rule number 4 states that the sum of the angles along a straight line, that is to say the sum of the angles along the straight line OC at a certain point in the left side of the straight line OC must be equal to 180 degrees. Therefore, this angle, that is 90 degrees plus angle OEB, must be equal to 180 degrees. Okay, so this is according to rule number 4. According to rule number 4, the sum of the angles at a certain point along a straight line and the in the left side of that straight line must be equal to 180 degrees. Therefore, 90 degrees plus angle OEB must be equal to 180 degrees. Okay, so from this equality we will subtract 90 degrees and we will get that angle OEB equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle OEB equals to 90 degrees in its size. So actually this angle is a right angle. Angle OEB equals to 90 degrees in its size. So this angle is a right angle. So actually around point E we have 3 right angles that in total are equal to 270 degrees in their sizes, because it is 90 degrees times 3 equals to 270 degrees. Okay, so we can write down that the sum of the 3 angles around point E, this point, is equal to 270 degrees. Okay, so I'll read again the fixed interval. According to the drawing, the sum of the angles around point E is equal to 270 degrees. And if we define the 4th angle as Y, that is to say the 4th angle equals to Y degrees in its size, we have a rule number 5, that states that the sum of the angles around a point equals to 360 degrees. Okay, so I'll write it down. According to rule number 5, the sum of the angles around the point equals to 360 degrees. I will read rule number 5 again. Rule number 5 states that the sum of the angles around the point equals to 360 degrees. So if we focus at point E, then according to rule number 5, the sum of the angles around point E equals to 360 degrees. And what is the sum of the angles around point E? It is 270 degrees, that is the sum of the three right angles, plus the size of angle y, or plus y, must be equal to 360 degrees according to rule number 5. Okay? Again, according to rule number 5, the sum of the angles around point E must be equal to 360 degrees. And what is the sum of the angles around point E? It is the sum of the three right angles that are equal to 270 degrees in total, plus the size of the fourth angle, angle Y, must be equal to 360 degrees because of rule number 5 that states that the sum of the angles at any point is equal to 360 degrees. So if we subtract from this equality 270 degrees, we will get that the size of angle y equals to 360 degrees minus 270 degrees, y equals to 90 degrees. Okay, y equals to 90 degrees. So actually this is angle OED is a right angle, it equals to 90 degrees. Okay, so we found out that all the angles around point E are right angles. Okay, so in the next step we will focus on the right triangle, triangle ADB, this triangle, and the small right triangle, triangle OEB. Triangle ADB is a right triangle because it has angle ADB that equals to 90 degrees, and triangle OEB is also a right triangle because angle OEB equals to 90 degrees. Okay, so I will draw again those two triangles. So I draw again the big triangle, triangle ADB, and the small triangle, triangle OEB. As you can see from the drawing, those two triangles are right triangles because they has the big triangle has angle ADB that is a right angle, and the small triangle has angle OEB that is also a right angle. Therefore, those two triangles are right triangles. So actually we can write down that angle ADB equals to angle ADB in the right triangle ADB equals to angle OEB in the right triangle, triangle OEB. Okay, so angle ADB in the right triangle ADB equals to angle OEB in the small right triangle OEB, and both those two angles equal to 90 degrees, therefore they are also equal to each other. Okay, so those two angles are right angles, therefore they are equal to each other. And also we have angle B that is a common angle it belongs both to the small right triangle, triangle EOB, and angle B equals to also belongs to the big triangle, to the big right triangle, triangle ADB. So we can write down that angle B equals to angle B. It is a common angle. Common angle. It belongs to both triangles. And the third angle, the third pair of angles, angle BAD in the big triangle, also equals to angle BOE in the small triangle. Angle BAD equals to angle BOE. Those two angles are equal to each other according to third angle theorem. Third angle theorem. Okay, angle DAB, this angle equals to angle EOB, so those two angles are equal to each other according to third angle theorem. Third angle theorem states that if you have two triangles that has two equal angles, then the third pair of angles also must be equal in those two triangles according to third angle theorem, because the third pair of angles completes the sum of the angles in the triangles to 180 degrees. So the third pair of angles also must be equal in those two triangles. Therefore, those two angles that are the third pair of angles must be equal to each other. Okay, so we actually proved that all the angles in the big triangle, triangle ADB, are equal to all the angles in the small triangle, triangle EOB. Therefore, we proved that the big triangle, triangle ADB, is similar to the small triangle, triangle EOB, according to angle rule. So I write it down. Therefore, the big triangle, triangle ADB, is similar to the small triangle triangle EOB, according to angle rule. So I will read again the things that I wrote. We actually proved that the big triangle, triangle ADB, is similar to the small triangle, triangle EOB, according to angle rule. When you prove that all the sides of one triangle are equal to all the sides of the other triangle, then you actually proved that those two triangles are similar to each other according to angle rule. Okay, so, and from the fact that those two triangles are similar to each other, the following relationship exists between the sides of those two triangles. The relationship is that OB over AB, OB the side of the small triangle, OB over the side of the big triangle AB equals to OE, that is the side of the small triangle, over AD, the side of the big triangle. Again, because of the fact that we proved that the big triangle is similar to the small triangle, then the following relationship exists between the sides of two triangles, the sides of those two triangles. OB over AB equals to OE over OA. Okay? OB over AB equals to OE over AD. Again, OB over AB equals to OE over AD. And so actually, what is the OB, the size of OB? OB equals to R. You can see from the drawing that OB equals to R, and AB is the diameter of this semicircle, therefore it equals to 2 times the radius. And we also know that AO is the radius of this semicircle because it starts from the center of the semicircle and ends at point A, that is a point on the semicircle itself, therefore OA is the radius of the semicircle. And we can see from the drawing that AB equals to R plus R, that is to say it equals to 2R, and the equality is OE over AD. The size of AD is 7 units. So in total, we found out that R over 2R equals to OE over 7. Here, R over R is 1, so R is cancelled. And we got here 1 over 2. So 1 over 2 equals to OE over 7. Okay, so here we will multiply this equality by 7 in order to get the value of OE. We will get that OE equals to 7 over 2 units. OE equals to 7 over 2 units, so we can write here that OE equals to 7 over 2 units. And what is the value of EC? EC equals to OC minus OE. Again, EC equals to OC minus OE. Okay, EC equals to OC minus OE. From the drawing, we can see that EC equals to DE minus OE. Is OC Again, from the drawing we can see that EC equals to OC minus OE. And what is the value of OC? OC is the radius of this semicircle, so EC equals to R minus OE. We have already found out that OE equals to 7/2 units. So in total we found that EC equals to R minus 7/2 units. Again, EC equals to R minus 7/2 units. Again, EC equals to R minus 7/2 units. So we can write here that EC equals to R minus 7/2 units. Okay, EC equals to R minus 7/2 units. So in the next step, we will focus on two right triangles. Actually, triangle CEB is a right triangle because it has angle CEB that is a right angle, and also triangle OEB is a right triangle because angle OEB is a right angle. So we have these two right triangles in the orange color, and we also know that side EB is a common side. It actually belongs to the right triangle CEB, and side EB also belongs to the right triangle EOB. So we can create the equality that states that EB square equals to EB square okay. The equality is EB square equals to EB square, and we will implement the Pythagorean theorem on these two right triangles. The Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, and we have 2 times EB in this equality, EB square. In the first EB square, we will implement the Pythagorean theorem on the right triangle CEB. So in this right triangle, EB square equals to CB square minus CE square. Okay, CB square minus CE square. And the second EB square will be related to this right triangle, to the right triangle EOB. Here EB square will be equal to OB squared, that is the hypotenuse squared, minus OE squared. OB squared minus OE squared. Okay, in total we got this equality that CB square minus CE square equals to OB square minus OE square, and actually CB equals to 15 units, so CB square is 15 squares. 15 square is 225 minus CE square. CE equals to R minus 7/2. So CE square will be equal to R minus 7/2 square, or equals to OB square. OB equals to R, so OB square is R square. minus OE square. OE equals to 7 over 2 units, so OE square will be equal to 49 over 4. So in total we got that 225 minus r minus 7 over 2 square equals to r square minus 49 over 4. So here we will open the brackets and we will get that 225 minus r minus 7 over 2 square is r square plus 7 over 2 square is 49 over 4 plus minus 2 times r times 7 over 2 equals to r square minus 49 over 4. So in total we got that 225 minus r square plus 49 over 4 minus 2 times r times 7 over 2. So here 2 over 2 is 1, so 2 is cancelled and we left with minus 7r. So here we will open the brackets in this equality and we will get that 225 minus r square minus 49 over 4 plus 7r equals to r square minus 49 over 4. So here we have minus 49 over 4 in this side of the equality, and we have minus 49 over 4 on the other side of the equality, so we'll cancel minus 49 over 4 because we have them both in both sides of the equation. In the next step we will add r square to this equality and we will get that 2r square equals to 7r plus 225. So in total we got that 2r square equals to 7r plus 225. Here we will subtract 7r and 225 from this equality, and we will get the following quadratic equation: the 2r square minus 7r minus 225 equals to 0. So we got the quadratic equation that states that 2r square minus 7r minus 225 equals to 0. The general formula for a quadratic equation is ax squared plus bx plus c equals to 0. So that is the general formula for a quadratic equation: ax squared plus bx plus c equals to 0. when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out. So first of all, we'll find the coefficients in our specific quadratic equation. Our specific quadratic equation is 2r squared minus 7r minus 225 equals to 0. So the coefficients of our quadratic equation is a equals to 2, b equals to minus 7, and c equals to minus 225. Okay, those are the coefficients of our specific quadratic equation. A equals to 2, b equals to minus 7, and c equals to minus 225. And the variable of our quadratic equation is r. So the general solution, the solution to the general quadratic equation, we want to find out the value of x. We have a special formula to find out the value of x. X equals to minus b plus minus root of b squared minus 4 times a times c over 2a. So that is the special formula that we will use in order to find the value of x, but here a, b, and c are the coefficients of the quadratic equation, and x is the variable of the general quadratic equation, but the variable in our specific quadratic equation is r. So x equals to r in our specific quadratic equation. So we will use this special formula to find out the value of r. So here x equals to r, so 7 equals to minus b. b equals to minus 7, so minus b is minus 7 is plus 7, plus minus root of b squared is b square is minus 7 square is 49, minus 4 times a times c, minus 4 times a is 2, so minus 4 times 2 is minus 8, times c is minus 225, over 2 times a is 2, so 2 times 2 is 4, so in total we got that r equals to 7 plus minus root of 49 minus 8 times 225 is actually 1800. So in total we got that r equals to 7 plus minus root of 49 plus 1800 over 4. So in total we got that R equals to 7 plus minus root of 49 plus 1800 over 4. 1800 plus 49 is 1849, so I write it now. So R equals to 7 plus minus root of 1849 over 4. So R equals to 7 plus minus the root of 1849 over 4. The root of 1849 is 43, so I write it down. R equals to 7 plus minus 43 over 4. Okay, we got that R equals to 7 plus minus 43 over 4. We have here two solutions for R. The first solution is R equals to 7 plus 43 is 50 over 4. So the first solution is 12.5. The radius of the semicircle is 12.5 units. Again, R equals to 50 over 4 is 12.5, so the radius of the semicircle equals to 12.5 units. And we have also the second solution, that R equals to 7 minus 43 over 4. Again, the second solution is that R equals to 7 minus 43 over 4. R equals to 7 minus 43 is minus 36 over minus 36 over 4 is minus 9. So the second solution to the quadratic equation is that R equals to minus 9, but because of the fact that R is the radius of the semicircle, it must be a positive number, it can never be negative number, so this possibility is incorrect answer, so we left only with the possibility that the radius of the semicircle equals to 12.5 units. So if the radius equals to 12.5 units, then the diameter of the semicircle, that is actually AB, it equals to 2 times the radius, and 2 times 12 over 12.5 is 25 units. Okay, so we found out that the diameter of the semicircle equals to 25 units. Okay, AB, that is the diameter of the semicircle, that also equals to 2 times the radius, equals to 25 units. Okay, so now I summarize the lecture. Actually, we wanted to find out the diameter of this semicircle, that is actually the size of AB, because AB is the diameter of this semicircle. and we know that chord AD equals to 7 units, chord DC equals to 15 units, and chord CB equals to 15 units also. And we want to find out the size of AB, that is the diameter of this semicircle. So the first thing that we did is we did a construction. We joined together points D and B by a straight line, and we created angle ADB, that is a peripheral angle. According to rule number 1, this peripheral angle equals to 90 degrees. And rule number 1 states that peripheral angle resting on the diameter of the circle equals to 90 degrees. So actually this peripheral angle, angle ADB, rests on the diameter of the semicircle. Therefore, according to rule number 1, this peripheral angle equals to 90 degrees. Okay, and then we define point O as the center of this semicircle. Then we join together points O and C by a straight line, and we also join together points O and D by a straight line. Actually, OD, OB, and OA are the radiuses of this semicircle, because it starts from the center of this semicircle, that is to say from point O, and ends on the circle itself. Therefore, they are the radiuses of this semicircle. And then we focused on the green triangle and the orange triangle. We know that side DC of the green triangle equals to side CB of the orange triangle. It is given us in the question. We know also that OD, that is the radius of the semicircle, equals to OB, that is also the radius of the semicircle, so they are equal to each other because both those two sides are the radiuses of the semicircle. And OC is a common side, it belongs both to the green triangle and also to the orange triangle, so OC equals to OC. So we actually proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, we actually proved that the green triangle is congruent to the orange triangle according to side rule. When you prove that all the sides of one triangle are equal to all the sides of the other triangle, then you actually proved that those two triangles congruent to each other according to side rule. Okay? And because of the fact that the green triangle is congruent to the orange triangle, those two angles are also equal to each other because they are corresponding angles in congruent triangles are equal to each other, therefore they are equal to each other. And if we define one angle as alpha, then the other angle must be equal also to alpha because they are equal to each other. So angle OCD equals to angle OCB equals to alpha. Both those two angles are equal to alpha. Then we focused on triangle DCB, this triangle. In this triangle DCB, side BC equals to side DC. Both of those two sides are equal to 15 units, and we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. So in triangle DCB, this triangle, we have two sides that are equal to each other. Therefore, in front of this side we have this angle, and in front of this side we have this angle. So those two angles are also equal to each other according to rule number 2. And if we define one angle as theta, then the other angle must be also equal to theta, because they are equal to each other. And okay, and then we define this point as point E, and we focused on the orange triangle, triangle CEB, and on the green triangle, triangle DCE. In those two triangles, we know that side BC of the orange triangle is equal to side DC of the green triangle. Both those two sides are equal to 15 units, and also those two angles are equal to each other, and also OC is a common side, and it belongs both to the orange triangle and also it belongs to the green triangle, so OC equals to OC. So we actually proved that two sides and the angle included in the green triangle are equal to two sides and the angle included of the orange triangle. Therefore, we proved that those two triangles can go into each other according to side angle side rule. Okay, therefore, from the fact that those two triangles can go into each other, we can deduce from it that angle CEB is equal to angle CED, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so those two angles are equal to each other, and therefore we defined this angle as x, and the other angle must be also equal to x. So angle DEC equals to angle BEC equals to x. Okay, and we know that DB is a straight line because we constructed DB, we connected points D and B by a straight line, so DB is a straight line. And we have rule number 3 that states that along a straight line, either in the upper side or the lower side, at a certain point, the sum of the angles is equal to 180 degrees. So along the straight line DB, at a certain point, that is to say at point E, on the upper side of this straight line, the sum of the angles is equal to 180 degrees. That is to say, angle DEB equals to 180 degrees, according to rule number 3. This angle equals to 180 degrees according to rule number 3. That is from one side, but from the other side, the size of this angle, angle DB, is equals to x plus x according to our definition. So we actually have the equality that states that angle the 2x equals to angle DB equals to 180 degrees. From this equality we can conclude that 2x equals to 180 degrees. And if we divide this equality by 2, we will get that x equals to 90 degrees. Okay, so angle X, this is angle X, so it equals to 90 degrees, and this is also angle X, it equals to 90 degrees. So those two angles are equal to 90 degrees. So then we know that chord OC is a straight line because we connected together points O and C by a straight line. And we have rule number 4 that states that the sum of the angles along a straight line, either in the left side or the right side of the straight line at a certain point, is equal to 180 degrees. So if we look at the straight line OC at a certain point, point E, in the left side of point OC, the sum of the angles are equal to 180 degrees. So this angle, that is a right angle, equals 90 degrees plus angle EOB equals to 180 degrees. Again, if we look at the straight line OC at a certain point, point E, and at the right side of the straight line OC, the sum of the angles equals to 180 degrees. So 90 degrees plus the size of this angle, that is actually angle OEB, equals to 180 degrees. So the implementation of rule number 4 in our drawing is that 90 degrees plus the size of angle OEB equals to 180 degrees. From this equality we subtracted 90 degrees and we got that angle OEB equals to 90 degrees. So this angle is a right angle. So we actually found out that, and the sum of three angles around point E is 90 times 3 times 90 is 270 degrees. Around point E we have three right angles that the sum of them is 270 degrees. So we define the fourth angle as angle Y, and we have rule number 5 that states that the sum of the angles around a point equals to 360 degrees. Okay, and if we focus on at point E, the sum of the angles around point E will be equal to 360 degrees according to rule number 5. So actually we have already found out that the sum of the three angles around point E is 270 degrees. So 270 degrees plus the size of the fourth angle, that is Y, according to our definition, must be equal to 360 degrees according to rule number 5. Again, 270 degrees plus the size of the fourth angle, that is Y, according to our definition, must be equal to 360 degrees. From this equality we subtracted 260 degrees and we found out that angle Y equals to 90 degrees in its size. So we actually found out that all the angles around point E are right angles. Then we focus on two triangles, on triangle ADB and on triangle OEB. Those two angles are right angles, therefore they are equal to each other. And this angle, angle B, is a common angle. It belongs both to the small triangle, triangle OEB, and it also belongs to the big triangle, triangle ADB. So angle B equals to angle B. It is a common angle, and the third pair of angles, those two angles are also must be equal to each other according to the third angle theorem. The third angle theorem states that if you have two angles in a triangle that are equal to the two angles of the second triangle, then the third pair of angles must be also equal in those two triangles according to the third angle theorem, because the third pair of angles must complete the sum of the angles in a triangle to 180 degrees, therefore they are also equal to each other. So those two angles are equal to each other. So we actually proved that all the angles in the big triangle are equal to all the angles in the small triangle. Therefore, those two triangles, triangle ADB is similar to triangle OEB according to angle similarity or rule. And from the fact that those two triangles are similar to each other, the following relationship exists between the sides of those two triangles. That is to say, OB over AB equals to OE over AD. Again, OB over AB equals to OE over AA over OA or AO. Or OB over AB equals to OE over AD. Okay, and what is the size of OB? OB equals to R and AB equals to 2R. It is the diameter of the circle, and AD equals to 7. Okay, in total we got that R over 2R equals to OE over 7. Then R over R is 1, so here we got this equality. From this equality we got that OE equals to 7 over 2. OE equals to 7 over 2, and EC, what is the size of EC? EC equals to OC minus OE. That is to say, EC equals to OC is the radius, and OE is 7 over 2, so EC equals to R minus 7 over 2. Okay, EC equals to R minus 7 over 2. Then we have here two right triangles. Triangle ECB is right triangle because this angle is right angle, and triangle OEB is also right triangle because this angle is right angle. So we created this equality that states that EB square equals to EB square. And we should remember that EB is a common side. It belongs to both right triangles. It belongs to the right triangle, triangle ECB, and EB also belongs to the right triangle, triangle OEB. So we implemented the Pythagorean theorem 2 times on those two right triangles. EB square relates to this right triangle. EB square here equals to CB square minus EC square. Okay, it equals to EB square equals to CB square minus CE square. And then the other EB square is related to this right triangles. Here EB square equals to OB square minus OE square. Okay, EB square equals to OB square minus OE square. And we know that CB equals to 15 units, so CB square is 15 squared, this is 225. CE equals to R minus 7 over 2, so CE square is R minus 7 over 2 square. And OB is R, and OE is 7 over 2. So in total we got the 225 minus R minus 7 over 2 square equals to R square minus 49 over 4. So we solved this equality and we got to this quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, And we have our specific quadratic equation that states that 2r squared minus 7r minus 225 equals to 0. And the coefficients of our specific quadratic equation is a equals to 2, b equals to minus 7, and c equals to minus 225. When the variable of our quadratic equation x equals to r, and we have the formula to find out the variable of this quadratic equation is this formula. And in this formula we know all the variables, so we put the data inside this formula, and we found out that the radius of the semicircle is 12.5 units. We have also the second solution that states that the radius of the semicircle equals to minus 9, but because of the fact that the radius of the semicircle must be a positive number, it cannot be a negative. It cannot be minus 9, that is a negative number. Therefore, the only solution that is left is that the radius of the semicircle equals to 12.5 units, and the diameter of any semicircle or circle is 2 times the radius. So the diameter that is AB is 2 times the radius, and the radius equals to 12.5 units. So 2 times the radius is 2 times 12.5 units. So the final answer is that the diameter of this semicircle equals to 25 units. Again, AB, that is the diameter of this semicircle, that is also equals to 2 times the radius of this semicircle, equals to 25 units. Okay, thank you very much.